Hello everyone, my name is Nathaniel Jones. My project is a real estate fraud detection library. I'll start by going over the basics of the project, some technologies that were used, the data set that I used, and any struggles that I encountered in the process. Then I'll go over findings, demos, and my conclusions and next steps. Internet rental scams are a common problem, especially in high-demand areas like New York City. Anybody who's looked for an apartment in an area like this knows that you can fall prey to some pretty sneaky scams, some more obvious than others. You can get something that looks like a nice low price, and sometimes you'll get a ridiculous story like, oh, out of the country, I'll need you to put down a security deposit before you see the apartment, things like that. So this is especially difficult to search for and prosecute in the case of online listings because they're usually fairly anonymous. One preventative solution is to automate the detection of anomalies in listings, like an unusually low price for the region, and this task is perfectly suited for machine reasoning. So the goal of this project is to apply machine reasoning tools to automatic detection of fraudulent real estate listings, geared specifically toward rentals. For this project, I used Python for web scraping and HTML parsing, and the PySpark machine learning library for machine learning algorithms. The algorithms I've used are just a basic map-reduced statistics for finding outliers such as apartments with really low prices or really high prices. I used k-means clustering for cluster-based anomaly detection that takes into account the relationships between parameters, and a random forest for an even more advanced approach toward that relational anomaly detection. Over the course of this project, I scraped about 1 gigabyte of data from Craigslist. It was 700 megabytes at the time of writing this presentation, but at this point, as of 12/20, I have about 1 gigabyte of data. The listings are stored in a collection of comma-separated value files. And each listing contains the following fields listed here: a unique ID that was generated by my web scraping code, the state and territory, the Craigslist region, any title that the poster put as a description, the listed price, date and time of listing, number of bedrooms, square footage, neighborhood. All these things are important for telling you whether a price is reasonable for the location of the apartment. The one thing I would really like to have had but is not provided in online listings is the physical address of the apartment. But since that would be self-reported in those cases, it probably would not be particularly useful for fraud detection, as it could be completely fabricated. So we'll have to go by neighborhood, which is also self-reported in this case. These CSV files are around 100 megabytes. About 100 megabytes apiece. So you can open them in a text editor if you need to for manual inspection and editing. It's much easier, of course, to use the big data tools, though. Some challenges I encountered in the course of this project included dataset visibility and availability. It turns out that Craigslist does not take kindly to web scrapers, and I probably should have noticed or read their robots.txt file or something like that, or paid attention to the articles telling me that they were aggressive about this sort of thing. But shortly after I started scraping the data, they banned my IP address, and I was able to use a VPN to get up to the project's 1 gigabyte minimum. But I would not recommend using the scraper code provided with my project for your own purposes, because Craigslist does retaliate to scraping. The choice of appropriate tool was a difficult question. I was originally thinking of using Bayesian networks, but decided that it was better to have a wide variety of slightly simpler classification tools and also the time-based. One of the most powerful things about a Bayesian network is the ability to put in this history and decide probabilities based on that history. That history here is less relevant as we only have each individual listing to go by, at least in the web scrapes data that I collected. Something like this could be used by listing sites that have the full history of all this data, but we don't have that. So I decided to switch over to k-means clustering and random forest. So for my findings, real estate listing sites, it turns out, are very possessive of their data. The toolbox is best to use from inside the listing company or inside a listing site so that access to the data is easy. The real estate listings can be statistically extremely skewed, not in smaller subsets, but occasionally you get someone who who accidentally puts a purchase for maybe $2 billion in the rental listing section. So errors like that produce very large outliers that skew the statistics of the distribution. Parameter relationships are very powerful. Clustering and random forest turned out to be very useful methods. And the relationships between the fields, such as neighborhood and price, are very strongly correlated. So here's some quick demos about the methods in this library. The first and simplest is collecting univariate outliers. This is very simply using MapReduce to process the data down to a mean value and a standard deviation, and then filtering by the standard definition of outliers to standard deviations from a mean. So here are a few from the New York City subset of the data I collected. If you see a 2-bedroom in Greenwich for $11 a month, something's probably incorrect. If you see a 1-bedroom in the North Bronx for $200, good luck with that. Some of these are upper end outliers, apartments listed for above market price, or that have a large number of bedrooms, and that pushes them above the standard deviation limit, or in a high demand neighborhood such as the Upper East Side. So these also might be legitimate, but some of these, especially the lower end outliers, are clearly in some sort of error or contain perhaps fraud. As far as clustering goes, I have some code. The final report has a more detailed description of the API, which has changed since I wrote these slides. But you can compute the clusters, k-means clusters, based on parameters standard to the PySpark API, and the method will output the smallest cluster for you. So you can try different parameter sets and examine the smallest cluster. And what this uncovered was that, especially for clustering, this is very powerful if a real estate company is abusing an online listing site to post duplicate listings. Those duplicate listings are all extremely similar to one another and will cluster exactly in the same place. So I uncovered maybe 400 duplicate listings posted by the same real estate company on Craigslist in an attempt to flood the search. Random forest anomaly detection, one example of this would be the purpose of this is to create a unsupervised random forest classifier. And the classifier will run across some set of the data to be trained, and then you can pull potentially fraudulent listings out of the remaining data. Now, this is assuming that fraudulent listings are less common than real listings, which have yet to verify this assumption. But assuming that most of the listings are legitimate, you can use this training method to create a forest that will try to identify those. It turned out to work fairly well. Some of the apartments posted, just like in the outliers example, looked fairly legitimate. Upon closer inspection, you might find something else in there, but most of these were also clear outliers or clear scams when you think about the price versus the neighborhood. This was a pretty useful method for paring down a large data set into a couple of points that you might want to look at more closely based on the relationships between the parameters, and could be very useful for business purposes. In conclusion, I believe this project has confirmed that anomaly detection algorithms in machine learning libraries such as Spark are useful for detecting error or fraud in online rental listings. Most likely the audience for this toolbox would be listing sites. Otherwise, the data is hard to access. The final version does in fact include all of these things. I was able to finish everything I plan to implement, and again, the final report has a more detailed description of the capabilities and API, as well as more detailed examples. So some next steps that could possibly be used to add on to this. This toolbox is still a little rough in its capabilities. It only has 3 of the machine learning methods. It would be nice to put other statistical analysis options in there, more post-processing and some other analysis tools. The one thing I really wish I had had time to integrate into this is textual analysis or some sort of implementation of TF-IDF. I bet you could tell a lot about a listing being fraudulent or not by the kind of text people use in the title description. Sometimes you might see something like all amenities included, or beautiful something apartment in all caps, and the style of the text could tell you a lot about the lister. Also, the best way to further advance this toolbox would really be to work with a listing site. Any next steps and more intensive testing would need a much larger data set and more extensive resources. These listing sites would have access to all their own data and history as well, so you could integrate Bayesian networks into this once you had that extra history. And the listing sites also probably have a lot more experience with what things might be signs of fraud. So that falsification function I mentioned earlier for the random forest algorithm would be a lot more accurate having input from a listing site, or even from, say, an FBI officer whose specialty is tracking down these types of fraud. So that's all I have. If you have any questions, my net ID is on the first page, and you can feel free to email me and discuss further. Feel free, of course, to download the final report and take a closer look. This toolbox is meant to be open source as part of the Safarine repository, so enjoy, make use, and learn. Happy holidays.